All right, so this is Unit 6, Day 3 notes. Here are your objectives. There are a lot of objectives, especially when you're talking about exponents and your exponent rules. I think these are one of the more difficult topics that we're going to be discussing. Although it is only in Unit 6, Unit 9 gets very deep, but I think these rules are, are just a lot. So please take note, pay attention, and let's get through this together. Okay, so Unit 6, Day 3. All right, so if you remember with your exponent rules, if the bases are alike and you're dividing, you are subtracting the exponents. Please remember that although that doesn't have anything there, it's an understood one. So what we would do is take b to the 7th, subtract 6, okay? And now here with the a's, you're actually having 1 minus 5, okay? So whatever's up top goes first, 7, and then minus 6, and then a to the 1 minus 5. 7 minus 6, of course, is 1, so we'll just put b. A to the 1 minus 5 is negative 4, okay? So if you have a exponent with if you have a negative exponent, it goes to the bottom of a fraction to become positive. This is b over a to the positive 4 now, okay? When it went down to the bottom, it became positive. If it was already at the bottom, say this was a negative 5, we could bring it to the top and make it positive. So this is your answer once you've done that, okay? All right, so let's move to the next starred problem. This one becomes b to the 5 minus 2, a to the 3 minus 4. 5 minus 2 is 3. And then 3 minus 4 is negative 1. Again, negative exponent goes to the bottom, positive exponent stays. And then it becomes b cubed over a to the 1 power. And when it comes down, the exponent becomes positive, just like here. When it went down, the exponent became positive. Here, the exponent becomes positive 1. So that is why it's here. And we do not show a positive 1. Okay. All right, next starred problem here. Now they're getting into the numbers. You just have to simplify these numbers, okay? And again, subtract the exponents. So how would we simplify that? I can put it in my calculator. I don't know why I grabbed my phone. My phone is right next to it. All right, so, and it'll be 20, turn it on, it might help, 20 divided by, and I usually will push that ABC so that right above the sign, so that my answer will become a fraction. It'll simplify a fraction for me, 5 over 9. So this becomes 5 over 9. And now with the u, it'll be 5, sorry, that's my Alexa. All right, so it'll be 5 minus 3, and this one would be b to the 5 minus 5, which basically cancels each other out, okay? So this now cancels out because it's b to the 0, and anything to the 0 power is 1, okay? So this now becomes u squared, u squared, which is positive. So this becomes 5u squared is at the top. Why? Because 5 minus 3 is positive over 9, okay? And the b's look like they just canceled each other out, all right? That became 0. All right, not the whole thing becomes 0, but 5 minus 5 is b to the 0 power, which is 1. And 1 times anything is itself. That's why you don't see the 1. All right, so let's do the same thing here. 8 divided by 32 became 1 over 4. So this is 1 over 4. And then it's going to be x to the 5 minus 3 and y to the 5 minus 4. So of course this becomes now 2. That becomes 1. So on top, you'll have x squared, y to the 1 power, okay? The 1 can go away. If there's nothing left up top, imagine there's nothing up top, then you'd have that 1 up there. But in this case, x squared y is up top, and then the 4 is at the bottom still, okay? So we're just following our rules. All right, so let's look here. Star problem. Now we're having a power raised to the power. So let's figure out what's in here first, and then we'll get to this 2 on the outside, okay? So 2, 8, you can, you can distribute, you can simplify by dividing both by 2. That now becomes what? 1. A to the 6 is by itself, really. And then we have b to the 5 minus 3. All over this 8 divided by 2 became 4. And then, of course, with the b's, we kind of put it up there with it. So that becomes, and that's all to second power. So now this becomes a to the 6. I got rid of that 1. If the 1 is up there with it, I don't need to see it. B squared over 4. Okay. 5 minus 3 became b squared. And then raised to the second power. So for that particular situation with this, every single thing needs to be squared. So when you raise a power to a power, you are multiplying, and we saw that before too. You're multiplying 6 times 2. So this now becomes a to the 12, b to the 4, okay? And then what is 4 squared? We're not multiplying 4 times 2, it's 4 squared, 4 times 4, basically. And that is 16. Okay, so every single term had to be squared. Every term had to be squared in this situation. That's how we got this. Now I'm going to grab a piece of paper. I like to have room. Okay, I cannot stand it when I do not have room. So I'm going to grab a piece of paper and write it out. Make sure I write it correctly, because sometimes if I write it wrong, my whole answer will be wrong. And I've done that before. All right, so x to the 7th over x cubed. And that's an important lesson for you all, because like if I've written it wrong, which I've done before, I'm doing a problem that is wrong. And for you all, you are taking your test on ALEKS, you have to kind of write it out and show your work on a separate sheet of paper. So if you write it wrong, then of course you're going to get the wrong answer. Okay, so all right, so I feel like we've written it correctly. Let me make sure. Okay, looks like it's fine. And now we can simplify. So here, when it's kind of like this, you have to do the exponents first. We are not going to do this first. Okay, we're not going to simplify those first because it's in its own separate exponent, and exponent has to go first. So here, this becomes 3 squared, and then x to the 4th squared over 4 cubed. And again, I want to kind of show you the process as opposed to just doing it, and then times x to the 7th cubed. Okay, so we split everything up. Everything has on the top, everything got a square. On the bottom, everything got a cubed. So now 3 cubed is 9. These two, when you raise the power to a power, you multiply. That becomes x to the 8th over 4 cubed is 4 raised to the 3rd power is 64. And then multiply 7 times 3, that becomes 21. Okay. Now, if this is kind of a thought process that you could have for this, instead of just subtracting and then negative putting down. If you had, imagine you had x squared up top and x to the 4th at the bottom. Basically what that means is there's 2 x's up top and 4 at the bottom. Okay. All right. So now what happens is these 2 cancel out. How many are left over? 2 at the bottom. So your answer, of course, if there's nothing up top, it'd be 1, would be 1 over x squared at the bottom. Okay. So the thought process with that is that you need to make sure, that's basically what's going to happen here. When you subtract, wherever the most x's are, that is where the leftover x's are going to go. So if I subtract if I subtract 21 x's from 8, I'll get 13. Basically, 21 minus 8 is 13, and the 13 x's are left at the bottom. Okay, I'm going to turn this light off. It's giving me a glare, I think. All right, so this is going to be 9 over 64, and then x to the 13th is left over at the bottom. Now, can we simplify that 9 and 64? We can see 9 divided by 64, and it does not simplify. When it gives you the same exact, it doesn't simplify, so this is your answer. And then the 13 x's are left at the bottom, okay? All right, let's go. So that's what we got for this one. We got 9 over 64x to the 13th power. That's our answer there. All right, let's go to the next section. Anything raised to the 0 power is 1. So it's not 0, it's 1. So in this case, we have -3, but 2 over 3 is raised to the 0 power. 2 over 3. The -3 is not. It's out here by itself, minding its own business. This 2 over 3 is raised to 0 power. So that whole situation becomes 1. So your answer is -3 times 1, which is -3 in this case. Okay. Like I said, anything raised to the 0 power is 1. So this answer is 1. Okay. And of course, with this one, the negative's on the outside. So 9 is raised to the 0 power. So this would be negative, it still has to stay there, but this is 1. So your answer would be -1. Here, this whole situation is raised to the 0 power. So that whole situation is 1. You'd have 2 times 1, which is 2. Okay. All right, so next problem. All right, so for this situation, you can put this in your calculator, but you really don't have to. Basically, there's going to be 6 zeros with that, but it's going to be at the bottom of a fraction. So 1 and 1, 2, 3, 4, 5, 6 zeros is going to be your problem when you write it out. 1, 2, 3, I like to put the commas, 1, 2, 3, just count 3 back. It's actually 1 million, okay? So this is how you do this one. This will be our answer here. And in this, they want the power of 10. They want you to write it kind of like this. So you're going backwards. So they want you to write it like 10 to the power of whatever, okay? So in this case, you can have a negative exponent as your answer, which you will. So all you have to do is count the zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. This will be 10 to the -8. Why? Because the zeros, the numbers at the bottom of a fraction. Okay. So here, same thing. 1, 2, 3, 4, 5, 6, 7, 10 to the -7. They want your answer just to be in the power of 10. Okay. They don't really. Usually, you cannot have an answer that has a negative exponent. In this case, they want your answer to be written as a power of 10. So they want it to look kind of like this. If it's at the bottom of a fraction, it has to have a negative exponent. Okay. Here, rewrite the following without an exponent. Okay. So in this case, you can actually put this in. And let's see if that works. I don't think you can put a negative exponent at the bottom in your calculator, but let's try. 1 divided by, and then we can say parentheses, 2 raised to the -4 power. I don't like that anyway. No, they don't like that either. All right, so if you have a negative exponent at the bottom of a fraction, bring it up to the top of a fraction, okay, to make it positive. So I'm going to bring this up to the top. This now becomes 2 to the +4. 1 times 2. 1 times anything is itself. That's why I just left it as 2 to the +4. We can definitely put that in our calculator. 2 raised to the 4th power, that gives us 16. Okay, so we get 16 there. Here, I can actually put this in my calculator now. I can say 9 raised to, 9 over 7 raised to the -2 power. And my answer becomes what? 49 over 81. So what happened? Let's understand processes here. What happened? So in this situation, when you have a negative exponent and a fraction, what you do is take the reciprocal, and you should know that word. I flipped the fraction, okay? When you flip the fraction, this now becomes, the exponent now becomes positive. So how did I get rid of this negative exponent? I flipped the fraction. Okay, and now it becomes positive. So now it's going to be 7 squared over 9 squared, and that's 49 over 81. And that's how we got the 49 over 81 here. Okay, understanding processes is important, more important than answers. Okay, and in this case, again, how do I get rid of this negative 1? Make this 9 over 5, raised to the positive 1. And if it's raised to the positive 1, it's just itself. Okay, so that would be our answer there. All right. All right, so this situation, again, if you have a negative exponent out here, and what you're going to do is take this entire situation and bring it to a bottom of a fraction. What do I mean? So at the bottom of a fraction now, you'll have negative 5 raised to the positive 3 power, because once I brought it down, it's being positive. Nothing's up top, so I'm going to put a 1 there. Okay. And then what is negative 5 to the raised to the third power? Negative 5 raised to the third power is going to be negative 125. So this will be 1 over negative 125. That's going to be your answer. Okay, nothing crazy, just understanding, bringing this down, and then when it comes down, the number stayed negative, but the exponent became positive. So that's what you're trying to do, okay? Rewrite the expression without a negative exponent. Simplify your answer as much as possible, okay? Let's do the star problems. What has a negative exponent here, okay? What has a negative exponent is the x. The 6 is just by itself. The x is raised to the negative 4 power. So if I'm trying to get rid of this negative exponent, I'm going to bring it up. But the negative 6 is still at the bottom. Negative 6 is still here. But x to the negative 4 came up and became x to the positive 4 now. And the 1 kind of went away because 1 times anything is itself, so I'm not going to put 1 times x to the 4th. I'll just put x to the 4th. And then the negative 6. Can that negative 6 be at the bottom? Yes. We're talking about negative exponents, not negative numbers. Negative numbers are fine, but negative exponents have to be changed. That's why this exponent went to the top. So this is your answer. That's the furthest we can go. All right, same situation here. M to the negative 4 goes to the bottom, but the negative 6 stays up top. Negative 6 is still fine. That's this is the regular negative 6. But the m to the negative 4 has to go to the bottom of a fraction. Now this becomes negative 6 over m to the positive 4. Now the exponent is not negative. Okay, let's go here. M to the negative 4 goes to the bottom. The 3 stays up top. M now becomes m to the positive 4 at the bottom. Okay, we brought it down because we wanted to change the exponent to make it positive. All right, next. All of these are like, bases are alike, so we just basically add the exponents. Although that has nothing there, understood 1. So we'd add 4 plus 1 plus negative 8 or minus 8. 4 plus 1 minus 8, that becomes negative 3. Okay, so y to the negative 3. If it has a negative exponent, it goes to the bottom of a fraction to become positive. There's nothing up top, that's when you put that 1. Okay, when there's nothing left up top, we'll put the 1. All right, same situation here. We're going to have u. All of these bases are alike. We're adding, I'm sorry, we're not even doing that one anyway. We're just adding the exponents there. But okay, so this situation where you're multiplying the numbers, so the numbers 4 times 3 times 4 multiply all together. So the regular numbers, you just multiply. But here with the bases, we have to add the ones that are alike. So we're going to add 4 plus negative 8, which is minus 8. I hate to say plus negative. And those are the V's. The W's, there's a negative 1 plus what? Negative 1? I see a negative 1 there. And then X is going to be what? Negative 1 plus 1. So remember there's a 1. So let me add all those together. First of all, 4 times 3 times 4 becomes 48. Add 4 plus negative 8, that becomes negative 4. W is negative 1 plus negative 1 is negative 2. Okay. And this one is -1 plus +1. Guess what happens there? It becomes 0, x to the 0, which is 1. So it kind of like goes away. It's a 1. So now these negative exponents have to go to the bottom of a fraction. Bottom of a fraction, the 48 stays up top. This now becomes b to the +4, w to the +2. And this is your answer. Okay? Understanding exponent rules. So important. But also not very simple. I mean, it takes time to really get these. All right, number 3, times 4 times 4. I took all the numbers and multiplied them first. Now I have b, or b to the -7. So I see one here, I see a b here, I see a b here, b and +2. Then I have w, and I have w to the -1. And it looks like w to the +1, +1. And then u to the -9, and then +8. Okay, so I figured out all of my my b's go together, my w's go together, and my u's go together. So multiply 3 times 4 times 4, we get 48. And then combine those, that becomes b to the -5. W to the 0 power kind of goes away, okay, it becomes 1. And then u to the -1. So negative exponents go down, not negative numbers, negative exponents. So +48 over b to the 5th, u to the 1 power. That is my answer there. Okay. Look at this one. It has a negative exponent at the bottom and a negative exponent at the top. But they have the same base, so I will subtract them. So I will say y to the -4 minus -5. Okay, y to the -4 minus, because you're dividing -5. If I put that in my calculator, it can decipher it for me. -4 minus -5, +1. So your answer here is y to the +1. It's just y. If it was y to the negative, I'd bring it down. But it's not y to the +1, so that's fine. All right, so this one would now be x to the -5 minus 2. Okay. -5 minus 2 becomes -7. So this becomes x to the -7. Negative exponent has to go to the bottom if it's at the top, which it is. So this becomes 1. Nothing's left up top. X to the +7. Okay, that's your answer there. Good. All right, so next page, starred problems. These can get really tedious, but you have to understand your exponent rules. All right, so the m's here, subtract, n's here, subtract the exponents, p's here, subtract the exponents. So this becomes m to the -1 minus 2, n to the -4 minus 8, and p to the 7 minus -5. Okay, m to the -1 minus 2, 1 minus 2 is -3. Again, putting it in your calculator is fine too. So n to the -4 minus 8, and that basically is 8, 9, 10, 11, 12, -12. Okay, and this negative minus a negative becomes basically plus, 7 plus 5. Okay, this becomes a plus. So 7, 8, 9, 10, 11, 12, 12, p to the 12, +12. Okay, exponents that have negative exponents, they go down. Negative exponents, not negative numbers, negative exponents, the little numbers. So if it became like -3 right here, just a regular -3, it would stay up top. But in this case, p to the 12th stays up top. What goes down is m cubed n to the +12. So when they go down, the exponent becomes positive. Okay, that's our answer there. Let's get through this. 15 divided by 3, hopefully you know it's 5. And the m's have to be together. So this is -7 minus -2. N has to be together. So they tried to trick you here. -4 minus 8. So you see how they put the N first here and the M, but the M's have to go with the M's and the N has to go with the N's. Subtract them. You don't really feel comfortable doing it in your head, just put in your calculator, okay? -7 minus -2, -5, M to the -5, N to the -4 minus 8, that becomes -12, I believe. Yep, -12. Negative exponents go to the bottom, okay? So this becomes 5 over M to the +5, N to the +12 once it goes down. Okay, they become positive once they move to the bottom, the exponents. All right, so write your answer without using negative exponents. Right here, if you're raising a power to a power, you multiply. -3 times -7 is +21. So look, nothing you have to do there, okay? Two negatives become positive. Here, on the other hand, becomes u to the -12. It has a negative exponent, it goes to the bottom, because 4 times -3 is -12. So this becomes 1 over u to the +12 now. Okay, positive exponent when it went to the bottom. And this can give people fits. This whole exponent stuff can give people fits. All right, so negative here, negative power at the very outside. So what we're going to do is flip this. Remember, reciprocal. So this becomes 2w to the 4th over x to the 5th. And now this 4 out here is positive. Okay, so I flipped it because the 4 out there was negative. Now it's positive. Now I can distribute. So it basically is 2 to the 4th, w to the 4th raised to the 4th, and then x to the 5th to the 4th. So basically every single thing I made raised to the 4th. Okay, so 2 raised to the 4th here is 16. So this becomes 16 w to the 16, 4 times 4 is 16, over x to the 20th. No negative exponent, so I'm good. Okay, perfect. All right, so here I see a negative exponent. I can move it if I wanted to, but I can subtract those two. Okay, so inside I can subtract 4 minus -5. I'm leaving that squared outside. And then you know that if you're minus a negative, it becomes plus 4 plus 5. So this now becomes 3p to the 9 over 2, all squared. So now I'm going to have 3 squared, p to the 9th is going to be squared, and 2 is going to be squared. So 3 squared is 9, 9 p to the 18, because I have 9 times 2, and then over 4. Doesn't look like it can simplify there. That is going to be my answer. Okay. And then comes this page. All right, last page, but these are the ones that are all nasty and have all these things going on with them, of course, because they always do it. But take your time and just follow your rules, okay? So for me, I always have to have space. I need space, so I have to have adequate space. I'm going to transfer it to a piece of paper so that I'll have enough space, but I'll make sure that I write everything correctly. That is a big deal, okay? And it's also a deal breaker. So I have to make sure 3a to the -1 b cubed over 5b to the -3 a to the -5 all raised to the -2. So I have to make sure every negative is exactly where it's supposed to be, because if I write it down wrong, I cannot get it right. No matter how perfect I am, I have to make sure I get it right. And that's a -2. All right, so the numbers 3 and 5 doesn't look like they simplify at all. I'll leave those alone. But I do know that the A and B's here on the inside, I can do stuff with those. So this will be a -1 minus -5. And then for my B, it'll be 3 minus -3. Okay, all negative 2's on the very outside. I'm not doing anything with that yet. So now I have 3 over 5, and then I have a to the negative 1, basically plus 5, which is 4. A to the positive 4. And then 3 minus negative becomes plus. That's 3. 3 plus 3, which is 6. B to the positive 6. All that is raised to the negative 2 power. Okay? So that's what I did so far. Now, the negative 2 power has to go. What do I have to do to make this positive on the outside? If you remember, you have to take the reciprocal of the inside to make this positive. So what I'm going to do is I'm going to put 5 now up top, and at the bottom it's going to be 3a to the 4th, b to the 6th. Okay, all I did was split this exact thing here, and now this outside becomes positive 2. Okay, no more negative. Positive 2 now. Now I can distribute 5 squared over 3 squared times a to the 4th squared times b to the 6th squared. Everything has to get a squared. 5 squared is 25. 3 squared is 9. Now multiply 4 times 2 is 8. A to the 8th power, and then multiply 6 times 2, and that becomes b to the 12th. Okay, so this is my answer. But I had to have ample room. So good. So this is my answer. I can't simplify here. Doesn't look like it. And then they're all positive exponents, so that's fine. Okay. Let's go to the next problem. I might have enough room here to do it, but we'll see. All right, so it has a positive on the outside, so we don't have to flip anything. But inside, it's doing a little craziness with the negatives. So, and you can't, doesn't look like you can simplify because this is a V, a U, and a W. All right, so, but then if it has a negative exponent, I'm bringing it to the bottom. And if it has a negative exponent at the bottom, I'm bringing it to the top to make it positive. So this now becomes what? V, so V W squared, I brought the W squared to the top to make it positive, and this becomes 3U to the positive 4 all cubed. Okay, and this is V cubed, W to the negative 1. I could bring that to the bottom, but you don't have to right now. All right, so let me make that. So you know what you do here. This becomes V cubed. This becomes what? V W to the 6th power, because I'm multiplying 2 times 3. W to the 6th power. 3 cubed. What is 3 cubed? 3 times 3 is 9. 9 times 3 is 27. So this becomes 27. And this multiplied together, 4 times 3 is 12. U to the 12. Please don't forget that that's not 3 times 3. It's 3 raised to the 3rd power. It's not 3 times 3, which is 9. And that's where people mess up. But this is 3 raised to the 3rd power, which is 27. And now we have V cubed, W to the negative 1, okay, which basically just adds there. Okay, you combine the up top. So this becomes V, the V's you add, 3 plus 3 is 6. So this now becomes V to the 6th. Because if you understand that, it's over 1. So you just multiply straight across. And this is W to the 6th plus negative 1 or minus 1, which is W to the 5th. And then that 27 U to the 12th is still at the bottom. That's my answer. Okay, so it wasn't as much work to try to get through, but it still took some time. Okay, and this here, what they want you to do is, first of all, you have to do this first. You have to do the cube first. You can't just multiply straight across. We can't do that yet. We have to do the cube first because of PEMDAS. Parentheses, exponents come before multiplication. Okay, so you have to do that. So we're going to have x cubed over z cubed, just kind of left alone. And we'll do this first. Let's get rid of these negatives. We can bring this down and bring this up. Let's do that. So this became now 2u squared z squared over the x to the 1 came down and became x positive 1, which we kind of just showed that way. So that's the first thing I did. I got rid of the negative exponents. Now everything I can distribute, that cubed, okay, I'm leaving this alone. That becomes 2 times 2 times 2, not 2 times 3, which is 6. 2 cubed, 2 raised to the third power, which becomes 2 times 2, which is 4. 4 times 2 is 8. So that now becomes 8. Multiply these two, u to the 6. Multiply these two, z to the 6 over x cubed, okay? And now that we don't have that cube up there, now we can multiply straight across if we need to. Matter of fact, if you're multiplying, you can actually cross simplify, okay? If we're multiplying up here, we can cross simplify. So these x cubes canceled out, and this is where you're going. You'll be here soon. And then this is x to the 6th, and this is z to the 3rd. You can actually simplify there, or you're basically subtracting. So x cubed and x cubed, this now becomes z what? If you subtract 3 from it, becomes z cubed. Okay, because you're subtracting 6 minus 3. One is at the top and one is at the bottom. Okay, so now your answer will be 8u to the 6th z cubed. Okay, and if you do not feel comfortable with that, when we're moving into day 4 notes, we'll be doing all of this. In day 5, we're just going to be doing this a lot. So the more practice you get, the better you'll get at it. And that is Unit 6, Day 3 notes. Okay.